the square. I tell you what, that last video, man, solving for x, having that one variable term there, man, that made it easy to solve for x. All you had to do was undo what you see from the outside to the inside, and we got to our answer for x, and it was so quick and easy. You know what? I would love to be able to do that every time. So the key is you have to have one x term in the equation. Well, now we're going to look at what happens if you have two x terms, an x squared and an x and the constant. Your traditional trinomial equations. Well, normally what you do, like go down here, you see this and you attempt to factor it. All right. You would ask yourself, okay, here's my constant. It's a -7. Or you can just say the 7. There's two ways to look at it. What are two numbers that multiply to be -7? Okay, that's only -7 and a 1, or -1 and a 7. And they have to add up to be +8. Well, those two add up to be 6 or -6. It doesn't work. All right? So -7 is the problem. The other way you ask yourself this is you start from the left. What are two numbers that multiply to be 7 and subtract to be 8? 7 and 1. Okay, 7 and 1 subtract to be 6 or -6. It doesn't work. So since the -7 is the problem, we get rid of it. We just add it over to the other side. It's a problem. We don't want to deal with it. But when we add over the 7, I want you to also consider putting in a plus blank on both sides. And these blanks are going to represent the same number, and they're going to be the perfect constant, which means it's going to be a perfect square. Now, how do I find that number? Well, I look at the 8. The 8 is in the location of b. Okay, you're going to take the b, you're going to divide it by 2, and then you square it. This will be your perfect constant. So my steps, we'll take that +8, divide it by 2, gives me a +4, I square it 16. Wait a minute, why am I keeping the plus sign? Because it's a reminder that if this was a -8, you put a -8 in here. You have to include the sign. Trust me, there's a method to my madness, which is going to make your life incredibly easy. Now the authors, they'll tell you to put 16 in both blanks. I hate that. It is wrong. It's taking 2 steps backward, 1 step forward. What? Watch. Now that I have this perfect square 16, I would ask myself, what two numbers multiply to be 16 and add up to be 8? Well, it's 4 and 4. Wait a minute, I just had the 4. Why'd you make me change it? That's the method to my madness. So on the left blank, this is going to factor to x plus 4, x plus 4, which is going to give us x plus 4 squared, the binomial. So see this +4 being squared? Don't square it here because that's these two binomials. You need those two +4s there. All right? Step 3 means now you write this as a binomial being squared. Oh, wait a minute. This looks like section 9.1 problems. Oh my gosh, wait a minute. I went from 2 x terms to 1 x term, and that wasn't very hard to do. Get rid of the constant, add it over to the other side, or subtract it if it was a positive. Take half of a +8, that's a +4, square it. Okay, +4 squared here, 16 here, 7 plus 16 is 23. This becomes my binomial squared. Now, here's what we're going to do, is we're going to skip a step. We're not going to write this out. That's redundant. Notice that what's in my binomial inside my parentheses being squared is each individual term up here being squared. So we're going to shortcut this. Okay, x is being squared, put x in the parentheses. +4 is being squared, put in +4 in the parentheses. That's why I want you to include the sign, because that's the sign that you will have in your parentheses. So if that was a -8, -8, -4, -4 squared, I'd have a -4 here. Wait a minute, we can solve this. We're 2 steps away from being done. You take the square root of both sides, give me the plus or minus square root of 23, subtract over the 4 in front of my plus or minus, just like we did in the previous section, 9.1, And there's my answer. All right, now, in more, this author is going to take you through baby steps. So let me show you how to handle some of the homework questions. I don't like these just randomly are generated. I don't like it, but they're there. Okay, they have some use to them. Again, focusing on the b, dividing it by 2 and squaring it. So he will say, in order to complete the square of x squared minus 12x, so they're just looking, we've already put in the 2 plus blanks. We're just working on the left side. So he's really baby stepping us. Okay, so you would have to add what to the left side? Well, negative 12. I'm going to divide that by 2. That's going to give me a negative 6 squared. They want you to put 36 in the blank. This one, that's what I would add to both sides. But what would be my perfect square? That would be the binomial. Okay, x is being squared, negative 6 is being squared. Put those into the parentheses. X minus 6 squared. That's what they want right here. All right, now they might give us some ugly numbers. It's great when it's an even number because when you divide by 2, I get another integer. What if it's odd? Don't panic. Take that positive 13, divide it by 2. I can't. Then leave it as a fraction. It's perfectly fine. Just square both numbers. 169 over 4. That's what you're going to add. All right, so they want you to think, oh, here's your trinomial, how to factor this. No, you already know how it factors. You got your z squared. You got your plus 13 over 2 being squared. Those are the two numbers that go into your binomial squared. Just put that in the next text box. Oh my gosh, they gave me a fraction for b. Don't panic. When we divide by 2 to a fraction, it's like multiplying by its reciprocal, 1/2. Okay, well, wait a minute. If I multiply by 1/2, 2 can go into 18 9 times. So let's reduce it. Square the top, 81. Square the bottom, 49. That's what we want to add to both sides. Now, what's my binomial squared? T squared plus 9/7 squared. Okay, t plus 9/7 in parentheses squared. There it is right there. What is going on? There we go. All right, another form of the question they will have is they're going to say, okay, we want you to complete the square of this trinomial. We want you to put it in this format, x plus capital A squared plus b, and this is just their way of grading this really quickly by just putting in these two numbers, not typing in the whole completed square. They're just trying to save themselves some time. So here we go. 107, there's no two factors of 107 that add up to 16. So take that plus 107, and then we're going to add and subtract. So they're going to keep everything on one side of the equal sign. Again, baby steps. I know when we said in the work, when it's an equation, we add a plus blank and a plus blank to both sides. Well, there's no equal sign, so plus blank here, minus here. So half of positive 16 is going to be a positive 8 squared, so that's my plus 8 squared here. Square that to be 64. So now my binomial squared is the x and the plus 8 in the parentheses squared. Do the math here, 107 minus 64. That's 43. I'm in this format now. So A is equal to 8 and B will be equal to 43. Next example, oh, it's an odd number. Don't panic. X squared minus 9x plus blank. There's my 20. We have to subtract something to keep this all the same. Again, I'm telling you, I apologize. This is no equal sign here. It messes up. They're just baby stepping us through this completing the square. So minus 9, we're going to divide it by 2. There it is. We square it to 81 over 4. 81 over 4 is going to go in the second blank. My minus 9 over 2 squared is going to go in the first blank. Again, this builds my binomial squared. X is squared, put x in the parentheses squared. Minus 9 halves is being squared, put that in the parentheses being squared. That's this part. And then now 20 minus 81 over 4. Well, I need to have a denominator of 4. So multiply 4 to the top and bottom. This would be 80 over 4. So 80 fourths minus 81 fourths is a negative 1/4 or minus 1/4. So that's the B, and here's the A. Okay, now, whoa, wait, hold on. It said plus A, and I have a minus A. So that means I have to make my A the negative 9 halves. And this was supposed to be a plus B, but it's a minus. So this will be a negative, whoops, sorry about that, negative 1/4. So if it's just pluses, put in the number. If it's minus, you got to put the sign in with it, so don't make that mistake. All right, getting to solving. Here we go. This is the whole purpose of doing those steps. X squared minus 6x minus 2 equals 0. Unfactorable. No two numbers multiply to be 2 and subtract to be 6. Get rid of the minus 2. Add it over to the other side. Put in your plus blanks. Now, see, here's the equal sign. So here will be a plus blank on both sides to keep it balanced. So think of the equal sign as the balance point of a teeter-totter, if you will. If I add something to one side, I have to add it to the other to stay balanced. All right, let's build this blank. What's half of negative 6? Negative 3 squared is 9. Just like that, you got your numbers. All right, now we said the two items being squared, you put that into the parentheses being squared. The 2 plus 9 is 11. Bada bing, bada boom, I'm down to 1x. I'm 2 steps away from the answer. Take the square root of both sides. I get plus or minus the square root of 11. The parentheses are now gone. I can add over the 3, sneak that in front of the plus or minus, and just like that, we have the answer. And again, I have a calculator check. Here's the older version calculator. Before, in the last section, I showed you with the newer calculator. If you have an older one, it looks like this. 3 plus the square root, you hit the parentheses, you got to put in the 11, close the parentheses, store for x. But again, you type in the left-hand side, it equals 0. You only have to test one. If one works, the other one works as well. All right, next, there's no two numbers that multiply to be 3 and add up to be 10. So get rid of it. Subtract it over this time. So x squared minus 10x plus blank is equal to negative 3 plus blank. Okay, let's fill this in using our mental math skills. Half of negative 10 is a negative 5 that I want to square to be 25. Oh, that was pretty quick and easy. Okay, now, this is squared, this is squared. That goes into my binomial squared. Negative 3 plus 25 is a 22. And bada bing, bada boom, we're down to 1x. Undo what you see. Take the square root of both sides. We get the square root of 22. It's going to be a plus or minus. Now we're inside the parentheses. We add over the 5. That gives me 5 plus or minus the square root of 22. And again, there's my calculator check with the older screenshot from an older calculator. Put in 5 plus square root of 22, store it for x. Type in the left side, it's equal to 0, just like it says right there. Next example, x squared plus 3x plus 6 is equal to 0. All right, here we go. There's no two numbers that multiply to be 6 and add up to be 3. Subtract over the 6. Include your blanks with it. Oh, crud. This is odd. Oh, it's a fraction. Don't panic. Half of a positive 3 is a positive 3 halves. You square both the top and the bottom to get 9/4. Don't panic. You're not going to do any fraction work, I promise. My binomial being squared, x plus 3 halves in the parentheses squared. Now, think of this negative 6 plus 9/4 as a mixed fraction that you want to convert to an improper fraction. The steps to do that is you take the denominator 4, you multiply it to the negative 6, which is negative 24, you add it to the 9, and that's negative 15. That's not fraction work, people. 4 times a negative 6, there's no fractions there. Negative 24 plus 9, those are still integers, negative 15. All right, we're going to take the square root of both sides, but we have a negative, so don't forget, you got to take out the I. Square root of 15 on the top, square root of 4 on the bottom is going to give me a 2. I have my x plus 3 halves. I'm going to subtract 3 halves over, sneak it in front of my plus or minus. There's my answer. And screenshot, calculator check. This is how we type it in when you don't have that nice fraction option with the alpha y equals. It's negative 3 divided by 2 plus second decimal point for the I, square root of 15, close the parentheses because that closes off the numerator, divided by 2, store it for x. I type in x squared plus 3x plus 6, it's equal to 0, just like it says up here. I know this is correct. All right, x squared minus 9x minus 2 equals 0. There are no two numbers that multiply to be 2 and subtract to be a negative 9. Add the 2 over and put in your plus blanks. Oh boy, here we go again. Fractions, it's odd. Let's see, negative 9 over 2 squared. That's going to be a positive 81. This is always a plus over here because you're squaring. 2 squared is 4. Okay, again, my fraction on the right, 4 times the 2 is 8, plus the 81, 89 over 4. There it is. X squared, negative 9 over 2 squared, x minus 9 halves in my binomial squared. Down to 1x, undo what you see. Take the square root of both sides, plus or minus square root of 89 over 2. Can't simplify that. Parentheses are gone. Add over the 9 halves, sneak that in front of the plus or minus. And there's your calculator check. 9 divided by 2 plus the square root of 89. Close the parentheses. Divide by 2. Store it for x. X squared minus 9x minus 2 equals 0, just like it states right there. Oh, I like this completing the square. Man, this is great. Oh, crud. Wait a minute. Who put numbers in front of my x squareds? See, all these problems over here, it's great when it's a 1x squared. Well, you can also have numbers other than 1. Now, how do I work this? Well, now in order to factor, you have to multiply the a and the c together to get a number, and then find those two factors of that product to see what adds up to b. So normally here we would say, okay, 2 times negative 5 is negative 10. Are there two factors of negative 10 that can add up to be 8? Well, no, the only factors are 2 and 5. Or excuse me, 2 and negative 5, for that matter. Or negative 2 and a positive 5. Either case, it's either going to be negative 3 or positive 3. I can't get to an 8. So now both numbers are the problem I need to get rid of. Okay, well, let's see. Orders of operation for simplifying. Multiplication happens before subtraction. So we're going to divide everybody by 2. 2x squared divided by 2, 8x divided by 2, minus 5 divided by 2, and 0 divided by, wait a minute, 0 divided by 2, that will always stay at 0. Okay, boom, there it is. Okay, now I have a 1 in front of my x squared. And I can go back and complete the square. Don't panic, oh my gosh, we got a minus 5 halves. Just add it over to the other side, put in your plus blanks. We can work with these fractions because I've showed you really don't work with fractions. Well, let's find out. X squared plus 4, what's half of positive 4, is a positive 2 being squared, which is 4. Okay, what's the difference if I do 5 halves plus 4 or 4 plus 5 halves? it's still take the 2 times the 4 is going to be 8 plus the 5 is going to be 13 over 2. My x squared, my plus 2 squared. We put those into my binomial squared. Uh-oh, I just noticed something. I don't have a perfect square in my denominator. We're going to be taking the square root, and I don't have perfect square numbers. Make it. This 2, multiply the top and the bottom by 2. I can either do it now, or I can multiply by the square root of 2. I prefer to take care of it now. Top and bottom is multiplied by 2. That gives me a 4 on the bottom, 26 on the top. Now when I take the square root, I get plus or minus the square root of 26. Square root of 4 is 2. If you need a perfect square, you just multiply it by itself, top and bottom. Subtract the 2 over, sneak it in front of the plus or minus, and there you go is my two answers. It is solved for. All right, next example. We have 3x squared minus 9x minus 4 is equal to 0. Again, we're not going to panic. 3 times 4, or negative 4, is negative 12. There's no two numbers that add or subtract to be 9. 3 and 4, 2 and 6, nothing works to get to a 9. All right, we got to get rid of the 3. Divide everybody by 3. 3x squared divided by 3 minus 9x divided by 3 minus 4 divided by 3, 0 well, we really don't have to divide 0 by 3 because it's still going to be 0. Oh my goodness, we got to add over the 4/3. Put in your plus blanks. Notice I left myself a little bit of room here. I foresee a problem. Okay, we're going to slow down. Okay, here's my problem. This is odd. Okay, so if I take negative 3 or minus 3 and I divide it by 2, that's a minus 3 halves squared. That's 9 over 4. Well, 4 is great. That's a perfect square. But my 3 is not a perfect square. So I left a little bit of room here. I need to make this a perfect square, so I'm going to multiply top and bottom by 3. That's going to give me, on the right side, 12 over 9 plus 9 over 4. On the left, the x squared and the minus 3 halves, or negative 3 halves squared, that goes in my binomial squared, so we'll put that on hold. That's fine. I just got to look a little bit more at these two fractions, because I really can't add them together because my denominators aren't the same. Well, here's a great rule of thumb. Because my two denominators, this 9 and that 4, are perfect squares, if I want to make this a common denominator, if you just multiply the denominators together, a perfect square times a perfect square makes another perfect square. So we're going to multiply the first fraction by 4 over 4. That's this denominator being multiplied top and bottom over here. Then we're going to take this 9, multiplied to the top and bottom over here. So 12 times 4 is 48. 9 times 9 is 81. That adds up to be 129. Both denominators are a 36, so I'm just going to write the fraction with one denominator. And there's my fraction. Now I know it looks kind of scary, but if you actually look at all the work you did not do any fraction work. I'm sorry. 4 times 3 is 9, 3 times 3. Or excuse me, 4 times 3, 12, 3 times 3. Nope, 12 ninths. That's not fraction work. Multiplying straight across, adding across. That's not fraction work. I'm sorry. I know I seem kind of crazy. But, hey, we're going to take the square root now. We have a perfect square on the bottom. That'll be a 6 on the bottom, and you can't take the square root of 129. That's a prime number. So plus or minus that fraction. We have x minus 3 halves. We'll add over the 3 halves, put that in front of the plus or minus, and there you have it. There's our answer. There's always a workaround. You gotta love it. There's always a way to complete the square, no matter how ugly numbers they give you. Speaking of ugly numbers, here's the next example. 2x squared plus 5x minus 1. Okay? 2 times negative 1 is negative 2. There's no two numbers that multiply to be negative 2 and add or subtract to be 5. Get rid of the 2. Divide everybody by 2. Oh my gosh, we got fractions in both. Don't panic. Add over the 1/2. Put in your plus blanks. Leave yourself some space. Why? Because 2 is not a perfect square. So we're going to have to make an adjustment. Okay, oh, wait a minute. We got to take half of 5 halves. That's just multiplying the denominator by 2. That gives me a positive 5/4. I square it to get 25 over 16. All right, well, we got to make 2 into, wait a minute. I don't have to multiply by 2 because doesn't 2 go into 16 evenly? Yeah, 8 times. So let's multiply the top and the bottom by 8. Those are called goes into numbers. 2 goes into 16 8 times. So that will be 8 plus 25. That's just 33 over 16. Perfect. Perfect square in the bottom. I'm ready to go. Let's take the square root of both sides. The x squared comes in. The plus 5/4 squared goes into my binomial being squared. We take the square root. X plus 5/4 equals positive or negative. We can't take the square root of 13, but we can take the square root of 16, which is 4. Subtract over the 5/4, sneak it in front of that plus or minus, and ladies and gentlemen, there is your answer. Our next example, here we go. 4 times 8 is 32. There's no two numbers that multiply to be 32 that are going to add up to be 3. Just not going to happen. Okay, get rid of the multiplication of 4 first, so divide everybody by 4. That gives us x squared plus 3/4 x plus a 2 equals 0. Now get rid of the constant, subtract the 2 over, and we put in our plus blanks. Well, we got a fraction here again, so we got to work slow. So half of 3/4. Well, we saw that earlier. That's like just multiplying the denominator by a 2. So that's going to be 3/8, and it's going to be a positive 3/8 squared. That's going to be 9 over 64. Okay, so here we have a whole number. We have a fraction. We'll use our mixed fraction rule. 64. Okay, I might need your calculator for this. 64 times a negative 2. That's a negative 128 plus 9. Negative 128 plus 9. That's going to be a negative 119 over 64. So you might have to go to your calculator and say 64 times a negative 2, not minus 2, negative 2 plus 9. There's the numerator. Over here, the x is being squared, the plus 3/8 is being squared. That goes into my parentheses being squared. 2 steps away to be done. Take the square root of both sides. Oh, wait a minute, we got a negative. We're going to get an I times the square root of 119 on the top. The negative comes out as I. Then we have the square root of 119. Square root of 64 is 8. It's on the bottom. All right, we're inside the parentheses. Subtract over the 3/8. Sneak it in front of the plus or minus. And there's our answer. Now again, remember with your calculator check, if you want to use the I, make sure in your calculator you change the mode to that A plus BI. It's not going to take care of it and grade it if it says real. We have to have A plus BI highlighted in the mode. And that takes care of 9.2 for us.